Okay, observational studies suggest that moderate use of alcohol by adults reduces heart attacks and that red wine may have special benefits. One reason may be that red wine contains polyphenols, substances that do good things to cholesterol in the blood and so may reduce the risk of heart attacks. In an experiment, healthy men were assigned at random to drink half a bottle of either red or white wine each day for 2 weeks. The level of polyphenols in their blood was measured before and after the 2 week period. Here are the percent changes in levels for the subjects in both groups. So here are the changes, right? So part a fathom dot plot of the data is shown below. Use the graph to answer these questions. Are the centers of the two groups similar or different? So it definitely looks like the center for red is different than the center for white because it looks like it's higher over here, whereas white, the center looks like it's around here, right? So the centers are definitely different. Um, are the spreads of the two groups similar or different? So the spreads, however, do look somewhat similar, right? They do look somewhat normal, except red, it looks like it's a little left skewed, but we're going to do the test to see if that skewness really affects it or not. So we're going to see if these are both approximately normal so we can do our test later, right? So let's go ahead and do that in part A, right? So remember, this sample size is less than 15, so we're going to be using a two-sample t procedure, right? Since we're dealing with mean, because it's less than 15, it was 9 in the data set, right? 9 for red wine and 9 for white wine, right? So use two-sample t-test if the data in both samples or groups appears close to normal. So they do appear close, but we're going to test it anyway. Um, if the data are clearly skewed or if outliers are present, do not use t. So that's what we're going to test here. We're going to see if they are approximately normal, even though they do look somewhat normal, except this little skewness in the red. All right. So I have that here. The centers of the two groups seem to be quite different, with people drinking red wine generally having more polyphenol in their blood. The spreads, however, are approximately the same. They do look approximately the same, but we're going to test it, right? So here's that data I'm going to need. So I'm going to need my calculator. So I went ahead and put in the data. So now I'm going to go to menu. I'm going to do statistics, stat calculation, and one variable statistic, right? Um, and this is going to be X1 list A1, right? That's the red. And we're going to put this in C. This results in C because I believe B is already taken, right? Right. So here we go. So here is our data for our red, right? So our mean is 5.5. So the number was 9, right? The mean is 5.5 for red. And then the standard deviation, let's go ahead and go back. Standard deviation was 2.51, right? So let's go ahead and go there. So 2.51. The minimum, let's go here. So the minimum was 0.7. Quartile 1. Quartile 1 is 3.75. Okay, the median is 5.5. Oh, so the median is the same as the mean. So there is no skewness at all for that first one, right? For the red wine distribution. All right, so quartile 3. Quartile 3 is 7.75. And the max, let's go to the max. The max is 8.4. All right. So we're going to check for normality, right? Basically, we're checking first if there are any outliers, right? So that's what these formulas are for. So it's 3.75 minus 1.5 times the IQR, which will be 7.75 minus 3.75. And this is equal to negative 2.25, which is less than the minimum of the red wine, right? Which was that 0.7, right? So there are no outliers left of the distribution. Now let's check right of the distribution. So we have quartile 3, which is 7.75 plus 1.5 times 7.75 minus 3.75. And that will be equal to 13.75, which is bigger than the max of R, which is the 8.4. So this means there are no outliers, right? No outliers for that red distribution, right? So that red one at least is normal, right? Because the mean of R is equal to the median of R, so there is no skewness for the red distribution. Okay, so now let's come up with our numbers for the white. So let's go back to our calculator. So let's go to Menu, Statistics, Stat Calculation, One Variable Statistics, and then this one will be in the B, from B, and we want this to be in D, right? We want that to be in our D table. Oh, I guess we needed an E, right? Let's go ahead here, Statistics, Stat Calculation, One Variable Statistics, D, and then, so we definitely want the B, but E, okay? Because B is going to be our white, right? Our white guy here. Where's B? See, B for white, right? All right, so let's go to our statistics here for the white wine. So the number was 9 and X bar is 0.23, right? So the number is 9 and this will be 0.23, 3. And the standard deviation is 3.29. The minimum is, let's see that minimum, negative 5.9. Negative 5.9. The first quartile is negative 2.2. The median is 0.5. Right? So you can see the mean and the median's bigger than the mean, so that is left skewness, right? But we'll see if it's significant or not. Quartile 3, 2.9. The max is 4.1. All right. So now let's check for normality. So quartile 1, so that's negative 2.2 minus 1.5 times IQR. So the IQR would be 2.9 minus negative 2.2. And that would give us the negative 9.85, which is less than the minimum of the white, which was negative 5.9. So no outliers left of the distribution. Let's check this one. So this was 2.9 plus 1.5 times 2.9 minus negative 2.2, which is 10.55, which is bigger than the max of the white, which was 4.1. So there are no outliers for this. So this implies no outliers. All right. And like I said earlier, the mean is less than the median. So this implies left skewness. So we have to do the test to see if it's significant. We'll just see if the median is within 0.5 standard deviations of the mean, then it's not significant, right? So let's have, this will be 0.233 minus 0.5 times 3.29, 0.233 plus 0.5 times 3.29, and that'll give us the interval negative 1.412 and 1.878, right? So we can see that the median of white, which was equal to, the median of white, which was equal to 0.5, right? Is definitely in this interval, right? Is definitely in that interval negative 1.412, 1.878. So this implies slight, so slight left skewness. So not significant, right? So it'll be slight left skewness. All right. So we definitely know that they're approximately normal, so that we can use the t-test. So that even verifies sort of what we were looking at, right? Their spread looks somewhat the same, right? It's just their centers are different. The mean and the median, where they are placed, they're different. It's just red has higher polyphenol levels than the white, right? Okay, so now let's go ahead and do part B, right? So part B is construct and interpret a 90% confidence interval for the difference in mean percentage change in polyphenol levels for the red wine and white wine treatments. Okay, so our parameters of interest are mu of R is going to be the actual mean polyphenol level in the blood of men like these in the study after drinking red wine, and then use of W is going to be the same but for white. And we wish to estimate the difference, mu of R minus mu of W, at a 90% confidence level. So we should use a two-sample t interval for mu of R minus mu of W if the conditions are satisfied. And the first condition, of course, is random. This was a randomized experiment. Normal, we already checked it in part A, right? The independent condition, so let's see, nth of R has to be less than 1/10 of capital Nth of R, and nth of W has to be less than 1/10 of nth of W, where nth of R is the number of healthy adult men who drink red wine. I think it's safe to say that 9 is definitely less than or equal to 1/10 of all healthy young men who drink red wine, and 9 is definitely less than 1/10 of all healthy young men who drink white wine, right? So that means all the conditions are met. All right, so now we're actually going to do the confidence interval. The degrees of freedom, since this is a t-test, is going to be n minus 1, which is 9 minus 1, which is equal to 8. And since this is a confidence interval, we have to do it for both sides. So 1 minus 0.90 over 2 is equal to 0.05. So we're going to have to find our special t that goes with our confidence interval, right? Okay, so here's our table for the t, right? And our degree of freedom was 8, and it is, let's see, 0.05, right? 0.05. So let's go back here. So 8.05 is going to be the 1.86. Okay, so that's going to be our special t value. Let's go ahead and go back. So this is going to be x bar sub r was 5.5 minus 0.23 plus or minus, and that was 1.86, right? 0 times the square root of, this was the standard deviation of the red was 2.51 squared over the number was 9 plus this will be, the standard deviation here was 3.29 over 9. And then this turns into, let's see, 5.27 plus or minus 2.569. And that'll give us the interval 2.701 to 7.839. Okay, so there is a difference, right, between the polyphenol levels. We could have seen that in the graph, but in the dot plot. But yeah, there is a difference, right, because 0 is not in this interval. So our conclusion is we are 90% confident that the interval, the one that we calculated, captures the true difference in actual mean polyphenol levels in men who drink red wine and men who drink white wine. This interval suggests that men who drink red wine have mean change in polyphenol levels between 2.701 and 7.839, higher than the mean of those men who drink white wine. And then part C is talking about, does the interval in part B suggest that red wine is more effective than white wine? So, since the interval, this, does not contain 0, it does support the researchers' belief that the polyphenol levels is different for men who drink red wine than those who drink white wine.